Hey, and today we'll be talking about order and degree of differential equations. So first, let's start with order. The order of a differential equation is the highest derivative of a dependent variable present in the equation. Now, what does that mean? Well, let's use an example to clarify. So let's say we have an equation d squared y over dx squared plus 3 dy over dx plus y is equal to 0. Now, what is the order of this equation? This is a differential equation. What's the order? Well, the order is equal to 2. Why now? Well, that's because the highest derivative is d squared y over dx squared. Basically, it's because of this here. It shows that the order is equal to 2. And now let's move on to the degree of differential equations. The degree of differential equations is the power of the highest derivative, provided the equation is free from fractions and radicals with respect to the derivatives. I'll give you an example of this just now in a second. But once again, let's use an example to show what this is. So our equation is d squared y over dx squared to the power of 3 plus dy over dx is equal to 0. Now, what is the degree? Well, the degree is equal to 3. Why is this? Because the highest derivative, d squared y over dx squared, is raised to the power of 3. Let me just highlight it here. And now let's give an example where the equation has a radical. So let me move a bit to the bottom and let me write down the example. So this will be under root or square root dy over dx plus y is equal to 0. Now, what's the degree? The degree is undefined because, let's get the correct column, because of this is a radical here, so there is no degree. And that's it. This is a clarification of order and degree of differential equations. Hope it was clear enough, and thank you for watching.